Okay, page 11 starts another new section now. We've moved on to chapter 7 here. We really only covered 7.1 through 7.3. Just to remind you, if I remember right, I think 7.1 was how to graph linear systems, and that's what this first question asks you to do. Solve the linear system by graphing. 7.2, I believe, was how to solve a linear system by substitution. That'll be question 2. I'll do that in a few minutes. And then 7.3 happens to be on the next page, so it'll be a separate video, but that will be how to solve a linear system by linear combination. Well, let's get started with question 1, how to solve by graphing. If I've got two equations here, and that's a linear system is just two, or it could be more, but we really just looked at two different lines. That's what a linear system is, a system of more than one line, more than one linear equation. Well, here's one linear equation, here's another, together they make the system. And to graph it, you just have to graph the two pieces. Make that line, then graph that line, and the solution is going to be where they cross, where they intersect. So let's get started on that. My y-intercept for this one is going to be 3, and my y-intercept for the second one is going to be 4. And I'm going to indicate those by color, just so you can tell them apart. All right, so that'll be 3. And that'll be 4. Whoops, that didn't change color. Let's do that again. That'll be 4. So since we're on blue now, we'll start with blue. And so I'll indicate where I've placed the 4. So there's 4 right there. That's my y-intercept for that one. And my slope, well, it doesn't look like it has a slope, but it does. Slope is 1 over 1. So I go rise 1, run 1. And I make another spot. And then all I have to do is draw this line through them. Then I switch back to red like I'd said I would. Okay, my y-intercept this time is at 3. Y-intercept, remember, so it's intercepted by the y line. And this time the slope is 1 over 2. So I rise 1, run 2, make a spot, draw a line through the two of them, and it looks like the two lines cross, well, it looks like it's negative 2, 2. And that's what I say here. Looks like negative 2, 2. But what I want you to get in the habit of doing is checking. So plug it in. Plug it into each equation. The first one says y equals 1/2 x plus 3. We'll plug in 2 for y, like that, and negative 2 for x. So I've got 2 equals 1/2 times negative 2 plus 3. Negative 2 times 1/2 is negative 1. Negative 1 plus 3 is 2. And that's what I've got here. Negative 1 plus 3 is 2. And I check that off. That checks. Second one here, plug in the same numbers, 2 for y. So 2 equals negative 1 this time, plus 3. Negative 1 plus 3, yep, that is 2. Check it off. Or, I'm sorry, I'm looking at the wrong thing here. 2 equals, my bad, negative 2 plus 4. That's what we were talking about. Remember, y equals x plus 4. So 2 does equal negative 2 plus 4. Check that off. Good. That actually works. Let's move on to the next one, number 2. Like I said, this time we're going to be solving a linear system using substitution instead of graphing. And here are my two equations, my two linear equations. The bottom one looks just like one that we just did, y equals mx plus b, but the top one is not that format. The top one's in standard form. Well, one thing I can do is I can realize that any solution to a linear system is the place where they cross, where they have x and y in common. X and y are the same here. The x and y of the blue one are the same right at that spot as the x and y of the red one. Well, if that's true, well, that means this y is the same thing as that y. So I can say, since I know y is the same thing as negative 2x minus 6, I can substitute this part in for that y. So let's get going on that. X minus 2 parens here. Instead of x minus 2y, put parens in for that, equals negative 13. And in those parens, I put the y here. I put negative 2x minus 6. I substitute it in. So I've got x minus 2 times negative 2x minus 6 is supposed to be equal to negative 13. All right, so now I got to distribute this negative 2. Negative 2 times negative 2x becomes positive 4x. Negative 2 times negative 6 becomes positive 12. Now let's clean this up. X plus 4x is 5x. Plus 12 equals negative 13. Well, I want x by itself. Now I've just got the 1x. Now let's get it alone. Move the 12 over by subtracting it away, and I'm going to end up with just 5x on the left, and the right side is going to be negative 25. Well, if 5x is negative 25, then x is negative 5, like I say here. Now we plug that in to one of these equations. Let's plug negative 5 in here where it says negative 2x minus 6, and it becomes y is negative 2 times that negative 5 minus 6. Negative 2 times negative 5, positive 10. 10 minus that 6, 10 minus 6, is 4. And so my solution is where x is negative 5 and y is 4. It's that point. That's where those two lines are going to cross. And that's the end of this video. The next page is going to deal with question 3 on the still from chapter 7, but this time it's going to be about linear combination. So we'll end the video here and pick up where we left off on the next and final video.